Hey everybody, welcome back to part 2 of our Web Scraping 101 series, where we'll be going over more practical examples of how to use beautiful soup in a more functional manner. This is where we'll be going over actual examples using basketball reference to take information from the website and bring it back into a tabular form that we can use for whatever application you may have. For me, it's daily fantasy sports. If you have another application, all of these principles, all of these functions are more than capable of working for other applications. This is just the process and example I'm using for the purpose of this series. Now, this video is going to be a direct continuation from part 1, so if you haven't had a chance to watch part 1, I would strongly suggest going and taking a look at it. I'm going to go ahead and throw a link up here, up there, somewhere up there in the corner. I don't really know how YouTube works, so I'm gonna try and get something up there for you to click in to go right back to it. But we're gonna be picking up immediately where we left off. I didn't intend for it to be 2 videos when I recorded it. It just, the length was getting up there, so I wanted to break it up into more manageable sizes and lengths, because I know it's hard to stay focused for more than about 20-25 minutes with stuff like this. So yeah, if you haven't had a chance to watch part 1, go watch it, or if you haven't watched it in a little while, want a little refresher, hop back in, we'll pick up right where we left off. So we are going to work on pulling some information out of this table based on what I just showed you. So we're going to do soup, and this is just a quick check I like to do to make sure that I'm in the right spot. So I'm going to find all, table row, but I'm going to limit it to 2, because that's a whole lot of information to be pulling out if I want to find all the table rows. And we're fortunate on this page, there's only 1 table. If you're working on a page with multiple tables, then you'd need to find the right table, and then you can start to investigate that table. So I just want to look here, soup.findAll. None type object is not callable. Interesting. We have soup. Let's rerun that. Interesting. What have I done wrong? Soup dot find all. Aha. Find all. There we go. So the A needs to be capitalized. And those are the types of things that you can find in the documentation. So when you run across errors like that where you think it makes sense and you're not sure what's wrong with it, go to the documentation, look up the tool that you're trying to use, and figure out if maybe there's a parameter issue, maybe like I did, a capitalization there. Or it could be you've declared the soup object wrong. Not wrong enough that there's an error in declaring it, but wrong enough that you can't run the other functions on it. So there's all kinds of things that can point to errors like that, and it's just, experience and trial and error on figuring out what they are and how to deal with them. So as we look at here, soup, find all table rows, and if I wanted to find one, I could just do find, and it would just pull back the first one that it finds. So we have table row, rank, class, ranker, pop tip, and then position, and player's age. So this looks very similar to the information we just found over here, remember? We come down. So that's all the stats, looks good. And end of the table row, starting a new table row. Now we're on to Steven Adams. All right, and it's going to be the exact same information that we just looked up right here and inspect, which it is not wanting to let me do for some reason. Strange. Close you out. You over. And there we go. Okay. So, if we remember, that is exactly what we were seeing over here in the same format. Class, right, data stat, FG2A per game, field goal attempts per game. So we're getting the same information. So I know I'm in the right table, I'm in the right spot. So that's all I needed that for. And I'm going to be clearing some things out just to keep it easy to read while we're going back and forth, since it's going to be so zoomed in. Now that I know I'm in the right table, I'm going to define a new thing called header. All right. So now that we know that we're in the right spot and we're pulling the right information, I'm going to define header, and this is going to be where I want to pull out my table headers here. Zoom that back in. Yep, and the table headers are going to be basically the column names. So I'm going to do header equals, and I want to pull it out in a list. th table header dot get text, and this is a function that you can find in the documentation. This is just going to be getting the text value that's being displayed out of this cell. So I want get text for table header in soup dot find all table row limit equals 2, and I want first value there dot find all th. All right, I'm going to zoom out a little bit so we can walk through that function, and we'll just maximize this. So what I'm doing here, this is going to be list comprehension, and this is a little bit more of an advanced technique, but it's a much cleaner, much more efficient way to generate lists. So I strongly recommend that you take the time to understand how this is set up and try to implement it in your own code. So sometimes it's easier to start from the back, but we're going to go from the front here. So in my list, I want th.getText. I want those text values. So I want the text values for every th in soup.findAll table row limit 2, but only the first one. So each time it runs through and takes it, I only want the first text value. And then within the soup.findAll, we're finding all the table headers. All right, does that make sense? So let's look at it from the other way, because this is a soup function which allows us to run the find all table headers. So we're finding all the table headers, and then within all of the table headers, we are finding all of the table rows up to the second one. And we're getting the 0th value, which in Python indexes start at 0. I know I'm going to sound like a broken record, but that's something that can be very easily forgotten and can throw everything off. So we want the first text value for every table row in every table header, and we're going to be pulling the text value out for it. So let's run that, and let's look at header. Whoa. Header. Okay. So as you can see, we have every header value, right? So that worked. That gave us what we needed. So, and if you want to play around with statements like this, I would strongly recommend, if you're having trouble understanding what this does and why, play around with it. Write it on your own notebook and start taking chunks out. Like maybe take that chunk out and rerun it and see what header turns out to be. That's how I learned. That's an easy way to kind of figure out how this works. That's how I figured out that reading this from the back actually sometimes makes more sense as far as list comprehension goes. There's nothing wrong with that. It just makes more sense starting at the back, because this is more granular, getting up to big picture, whereas when you write it, you have to start at big picture and go down. So sometimes if I have a very complex comprehension statement, I'll start with the back end, write that, move forward, write that piece, move forward, and write that piece, working my way back to the actual beginning of it. So now that we've established we have the headers there, we don't necessarily need, for our purposes, rank. So one easy way to get rid of that is we're going to redefine the header function as itself, but only from the second position forward. Because again, Python starts at 0. So if we, let's comment this out real quick. So if we do header 1 forward, and I'd recommend you check before you actually assign it, because if I run this, it's going to print out the header list without rank, because I'm starting at position 1, because rank is at position 0. So if I run that, now I start at player. So usually I'll kind of run that in check before I reassign it, because once I reassign it, let's now comment that out. Now that it's reassigned, if I run header, rank's gone, because I've reassigned that variable to be this list without the 0th character. So just a little easy way to get something out so you're not carrying data through that you don't want. And you can do that for multiple columns. I just don't care about how it's ranked based on the sorted aspect of the, because I don't care how it's sorted. I just want the data. So we've gotten that out of the way. Now we need to actually get the data rows. And I'm going to do that by soup.findAll table row, but I don't need the first row, remember, because this is the first row. I need it, all of the data, starting just how we took that first column out of header. Now we're going to take that first row out of the data that we get, because I already have that stored here. I don't need it anymore. So we're going to get all of the rows. And let's go ahead and look at that. It's going to be big. Yep. So this is all of the data, including the rank, which again, we don't need. So we're going to deal with that in a little bit. But just to kind of show, this is a very large string, or list of strings. So we have all of our rows to work with here. That's good. Now what we need to do is actually get the relevant information out. So in a variable that I've defined as player stats, we're going to do another list comprehension. And this is going to be a list of lists. So we're going to do td.getText, because like up here we did thGetText. Now we want td.getText. That's going to be for the individual cells within that table that we're looking at. We're going to do td.getText for td in rows. And we want rows I dot find all td. Okay, and we're going to come out of the first list and say for I in range len rows. So looking at that, we have, and let's start again. Let's start from the back. For I in range length rows. So we have our rows. And if you remember, every single row, so Steven Adams was the first item in that list. So that's the first one. And then the next one is the next item in that list. So however long that list is, has however many times we need to iterate over this data. And this is where if you only were trying to get like the top 50 players points per game wise, then you would want to sort that table to begin with by points per game before you ran this. And you'd probably have I would assume the URL would update to be sorted. If not, you might have to do some Selenium, which we'll be going over in another video in the near future to interact with the web page. But then maybe you only want for I in range, 1 to 51, because it's already sorted by points per game and you just want the top 50 players. But for this purpose, we want all of the players. So for every row, with the row number being I, we want to look at the TD in rows I. And remember, rows is our variable there. So we're calling the ith row in rows, which again, just going to enumerate itself 1 through however many we have. So for every row, we want to find all of those values. And then what we actually want in the list is the td.getText. So just like we pulled out just the text value for the header, we're going to pull out just the text value for that stat. So now let's run that. And let's run player stats. So now we can see Steven Adams is the first one. Center, 26. Oklahoma City, 58 games played, 58 games started, 27 minutes per game. And we go down all of his stats in order. Bam Adebayo, who's number 2 on that table. Power forward, 22, Miami, 65 games played, 65 games started, 34.5 minutes per game. LaMarcus Aldridge, Nickeil Alexander-Walker, Grayson Allen, Jared Allen. So as you can see, we now have all the information we need. We just need to put it in a format that is going to be useful to us. So we have our player stats. We don't need to display it anymore. So now we just want all of our stats. So a variable I've just called stats. Now we're going to do td dataframe. td dot dataframe might help. And we want to build a data frame based on the player stats list of lists we have. And creating a data frame from different data sources, it's going to come in differently. If you're doing a list of lists, each list within that list is going to be its own row. So that's an easy way if you're pulling tabular data online down to a data frame, or if your end goal is a spreadsheet. Either way, bringing it in a list of list formats, it may not be the most efficient. I'm sure somebody out there could tell you a more efficient way of doing it, but it's very quick and easy, and it gets the job done and without a whole lot of work. So we need player stats as the data that we're bringing in to create the data frame. And then within pandas, there's the pandas.dataframe function. There is a columns variable where you can define the column names, and that's where we're going to use our header variable here, that list. And since we pulled all of the data down in order, we know it's going to come in order, so we just drop those headers on in order as well. Yeah. So we can run that. Then we can look at stats dot head. Let's look at the top 15, which is going to be the default for the head function. But so now you can see this is going to look just like what we have over here. Except instead of the rank, we have the data frame index, but we have Steven Adams, player, position, center, age, 26, team, OKC. The only things we didn't bring through are going to be these links. If you wanted to bring the links in, you certainly could. But game started. So we have the exact same column headers, and we have the exact same data there. So that's our data as we wanted it. And as we can see, 15 rows, 29 columns. That's just because we're looking at the top 15. If we want to verify that we got everything, we would look at this tail 15, and that's going to show us the bottom 15. So let's go ahead and hit the bottom and make sure that Zubac is, in fact, at the bottom here. And Zubac at the bottom. And then Ante Zizic, Cody Zeller, Trae Young, Thad Young. Yep. So we've got everyone. One downside of this type of data set, which you can see right here, is Marvin Williams. Anybody who's played on more than one team this season, Basketball Reference breaks out their stats based on the team they were playing for at the time, which is nice. If you're just looking for their season-wide stats, you're going to get 3 entries for one player, and that is not ideal. So that is something that we will be going over in a future video when we get into actually data usage and manipulation with pandas. But for right now, the purpose is, again, just to get the data. If this is all the farther you are comfortable going or want to go in pandas or Python for that matter, let's say that you are an experienced daily fantasy player and you already have your own spreadsheet analysis set up that you use to score players and judge trends in the game, and you just need a better way to get the data to update it with. You can use this method. You can use it on any website you want. And then once you get it, you can just put it into pandas and then drop it into Excel. So pd.dataframe to Excel. And we are going to call the table that we created, the data frame, because we're in Pandas. This is a Pandas function, so we need to call a Pandas data frame to send to Excel. And then you want to put where you're actually sending it. So we're just going to use the daily player list folder that we'd used previously. So I'm just going to copy as path by shift clicking my lineups file. And I'm just going to change that to stats. All right. And we'll make that an R string since we have slashes. Run it. It ran. Let's pull up stats and we should be able to see it all in Excel. Yeah. So one thing you'll notice here are going to be these empty lines. That is because we didn't do any cleanup. And if we come back to our basketball reference, come all the way up to the top, they're going to put in this header list again every 20 players. So if you notice, DeAndre Ayton is where it starts. DeAndre Ayton, and again, come down. That happens again after Davis Bertans. Davis Bertans happens again after Ignas Brazdeikis. Yeah. So as you can see, we didn't do any cleanup to take those values out. So that's something that we'll get to in a later video, actual data handling itself. I just wanted to give a little more detailed version of looking at how we're going to be getting the data. So if anybody has any comments, any questions about what I did, if you're having trouble getting it to work on your own, or if you would like to see more detailed web scraping information, let me know down in the comments. All feedback is appreciated, as always. All right, guys, that's going to do it for this video. If you liked what you saw, go ahead and hit that thumbs up down below the video so I know what you guys are enjoying, so I know what to make more of. If you want to stay up to date, our next series is going to be continuing the theme of web scraping, but we're going to dive into a new package. We're going to be using Selenium, which is going to allow us to interact with the website a little bit more. Beautiful Soup is great for pulling information out that's right there on the page ready to use. But sometimes it's not that easy. And to do anything beyond changing the URL, Beautiful Soup, it doesn't have a lot of answers for those questions and problems. Selenium does. So we're going to be diving into Selenium next, and we're going to be using NBA.com statistics to give a more advanced example of web scraping and how we can combine both Selenium and Beautiful Soup to really optimize our data gathering methods and get it done very, very efficiently. So I will see you guys in the next one.